If we've learned anything at all from the COVID-19 pandemic, it's that vaccines are crucially important. After all, we won't be able to fully return to our normal lives until a safe and effective SARS-CoV-2 vaccine is developed. The main job of a vaccine is to expose us to weakened or killed forms of an infectious agent. This is a way of warning the immune system about a particular virus or bacterium so we don't get sick if we're ever exposed to the full-fledged infection. It's a bit like seeing a wanted sign with the face of a criminal posted on it. Once our immune cells have seen a picture of the criminal, they can then respond appropriately if they ever see the criminal or virus in the real world. The focus of my PhD research is on developing a vaccine against Haemophilus influenzae. This is a bacterium that causes ear and lung infections, particularly in young children and older adults, but it also causes about 400 Canadians per year to develop severe infections such as meningitis. The specific issue I'm trying to address with my research is the fact that the current H. influenzae vaccine doesn't provide broad enough protection. This has to do with the fact that, kind of like cattle rustlers trying to escape from the sheriff, these bacteria wear disguises, known as polysaccharide capsules, which are these layers of sugar molecules that surround the bacteria cells and prevent them from being destroyed by cells in our immune system. In H. influenzae, there are actually 6 different types of these disguises, known as serotypes, in which are designated serotypes A, B, C, D, E, and F. There are even some strains of H. influenzae that don't wear disguises at all, and these are known as the non-typable H. influenzae. The current vaccine only targets serotype B, and this is a major problem because infections caused by non-B H. influenzae have become more and more common in recent years. This is why, instead of training the immune system to recognize the different bacterial disguises, which are different in each serotype and not present at all in the non-typable strains, the strategy that I use in my research project is to direct the immune response to a common feature of the outer membrane, or shell of the bacteria cell, which is a structure that is completely separate from the capsule, or disguise. This common feature is a protein known as transferrin binding protein B, or TBB, which is a protein that all strains of H. influenzae have. Based on the research I've done so far, it looks like we can achieve broad cross-protection against all strains of H. influenzae using a vaccine made from TBB. And in the remaining 2 years of my PhD, I hope to use the mouse model for H. influenza disease that I've been developing to confirm that this protein is indeed a viable vaccine antigen. So although this vaccine won't solve the COVID-19 crisis, it will help to save the lives of those of us who are most vulnerable to infectious disease.